Hey guys, here's the review for Unit 3, Unit 1, Topic 3. The population of my two SimCities are growing at different rates. The first, Joshburg, is tripling each year. So right away, Joshburg I know is going to be 3 to the x power, which is founded, Benville, which is founded 8 years later. That's important because this one had an 8-year head start, so I'm going to put plus 8, is growing by a factor of 9. That would be 9 to the x power. And how many years will the founding Joshburg will the population be the same? So I got to set them equal. When will they be the same? So I have to write 9 as the same base as the 3. So I'm going to write 9. Instead of writing 9, I'm going to write 3 squared. And then x power. And then 3 to the x plus 8 power. And then, so I'm going to do power of a power over here. 2 times x. So that's 3 to the 2x power. 2 times x. Which equals 3 to the x plus 8. Now that I have the same exact base of 3, I can set the exponents equal. X plus 8 is equal to 2x. Subtract x on both sides. You get x equals 8. Now, that is just when they both were, their populations were increasing together, because this one got an 8-year head start. So if x is 8, that means that the first one, Joshburg, has actually been growing for 8 plus 8, or 16 years. So from the founding of Joshburg, it's actually been not 8, but 16 years. I'm going to go ahead and do the rest of these. 9 and 27 can each be brought down to a power of 3. 3 squared, x plus 1. And 27 is the same thing as 3 to the third power, x plus 2. I'm going to do power of a power. 2 times x plus 1 is 3 to the 2x plus 2 power. And then here you have 3 to the x times x plus 2. So you have to actually distribute it just like we did before. And you get 3 to the 3x plus 6 power. And now I can set them both equal. And if you solve them, you end up with, if you subtract 2 on both sides and subtract 6 on both sides, you get x equals -4. All right, so the next one, 8 and 32. 8 I could break into 2 to the third, and 32 I could break down into 2 to the fifth. So 8 is 2 to the third to the x power, and 32 is 2 to the fifth to the x minus 6 power. So I'm going to go ahead and I'll go down here and I'll erase this later. So 2 to the 3 times x, that'd be 2 to the 3x power. This becomes 2 to, when you do 5 times this whole thing, to the 5x minus 30 power. And then, because now I have a base of 2, the only way they're going to be equal is if the exponents are equal. So I can set 3x equal to 5x minus 30. And if I subtract 5x on both sides, you get -2x is equal to -30. And if I divide both sides by -2, you get x equals +15. Okay, so I'm going to erase that now. So here you have 1 over 81 and 3 to the x minus 5. Now I know I can get, 81 is going to be 3 times 3, which is 9, times 3 times 3, which is 9 times 9, which is 81. So if I do 3 to the -4th power, I can actually get 1 over 81, which equals 3 to the x minus 5 power. So now that I can set the exponents, or the powers, as equal. And I'm going to add 5 to both sides and get x, 1 equals x, which is the same thing as x equals 1. Over here, 64 and 2, I can get 2 to equal 64, because I know that 16 times 4 is 64, and I can get 16 by 8 and 2. I can get 4 by 2 and 2, another 4 and 2. So if I actually multiply 2 times 2 times 2 times 2 times 2 times 2, I can get to 64. But it's 2 to the 1, 2, 3, 4, 5, 6th power. So I can change 64 to 2 to the 6th power, which equals 2 to the x plus 1 power. And now I can set x plus 1 equal to 6. And then now I know x equals 5. And the last one, 12 and 3. there is no way that I can bring down, there's no power of 3 that can get me 12. And there's no other power that can get me 3, which I can also get 12 to. So this one you cannot solve. There's no solution. There's no way this equation will ever be true. Here's number 3. You have 5 different ways of getting to the number 1 over, and this is 1, 2, 3. This is 1 million. Using the powers of 10, illustrating the laws of the exponent. So I can get to 1 over 1 million by doing, so you could do 10 to the negative second times 10 to the negative fourth, which equals 10 to the negative 6. That's one way to get to 1 over a million. I can just have 10 over negative 6 in the very beginning. I can do a division problem. So I got to somehow get to 10 to the negative 6. So I can do 10 to the second divided by 10 to the, because you're going to do 2 minus what number will get you negative 6? 8. So if you divided these two numbers, you would get 10 to the negative 6, which would equal 1 over 1 million. There's a couple different ways. I could have also done 10 to the third. I could cheat a little bit and just do the same concept, but just use different numbers. I can let's do a power to a power. So if I do 10 to the, so I need to get to negative 6. So 10 to the second to the negative third. You would multiply these numbers. So that would be 10 to the negative 6, and so forth. And you might have a different answer that, as long as it works, we're fine. Give the values of the exponents for y of each of the following when the expressions are simplified. So if I multiply this times this, it's 4 times the number in front, which is just a 1, because you don't see anything. So that's 4. And now that you're multiplying x to the 5th times x to the 6th, the way you multiply them is you can just add the exponents. You get x to the 11th. And y to the 4th times y, which is y to the 1st, gets you y to the 5th. And there's nothing to multiply z, so there's your, just leave the z, and there's your final answer. When you have a monomial to a third power, remember that 3 goes to everything. So you get 3 to the third, x to the third, and then power to a power, you multiply, get y to the 6th. And I can simplify that. 3 to the third is 27, x to the third, y to the 6. So it's 3 times 3 times 3. Here, evaluate. Remember, when you multiply, leave the base the same, and you can add the exponents. This one, 3 times 3 times 3 is not 81. You get 27. Here, you do 3 to the 7 minus 3. So when you're dividing, the way that you can divide when you have the same base is you can subtract. You get 3 to the 4th. And I believe 3 to the 4th is 81. So that one works. That one doesn't work. 3 to the second becomes 3 to the 4th, which is, again, 81, because you're multiplying the power to power. And here you actually get power to power. You get 3 to the negative 4th, which actually doesn't become 81, becomes 1 over 81. His mistake over here was you can't, this is not the same base. Even though you have 3 times 4, you have to get it down to one single base. And there was no way that you could have got 3 and 12 to be the same base. And that is the review.